All right, buckle up. We are talking about a technological arms race between two of the biggest names on the entire planet. This isn't just an upgrade. This is the quantum showdown.
Listen up, because this is the single biggest question in tech right now. It's not about a faster phone. This is about who will build the machine that unlocks the secrets of the universe and, maybe breaks modern civilization as we know it.
So in this corner, you've got the search giant with a mission to prove the physics, Google. And in this corner, the original titan of tech with a master plan to build the entire quantum economy, IBM. This is the heavyweight title fight for the future, period. And the prize? It's not just bragging rights. No way. It's control over a technology so powerful it could design new medicines overnight, crack climate change, and make every single password on Earth totally obsolete. The stakes could not be higher. But here's what's so wild. They're on completely different tracks. This isn't just a tech race. It's a total clash of philosophies. One is focused on building the perfect, flawless engine. The other is building the superhighway for everyone else to drive on. So, let's go to the tail of the tape. It's time to see what these champions are actually bringing into the ring. Forget the hype for a second. Let's look at the cold, hard specs. First up, Google's contender, the Willow processor. Look, this thing isn't just a chip. It's basically a scientific instrument. It's a 105-qubit beast, and it's engineered for one thing and one thing only: perfect, flawless quality. This is their weapon for achieving quantum error correction, the holy grail of this entire field. And in the other corner, IBM's champion, the Heron processor. It's a 156-qubit workhorse. This is the latest and greatest from them, and it's the rock-solid foundation of their massive, global quantum network that, get this, people are using right now, today.
Okay, let's break it down, head to head. Right off the bat, IBM has more qubits. But look closer. Google's Willow is the first chip to prove below-threshold error correction. That's a fancy way of saying it actually gets better the bigger it gets. Meanwhile, IBM has these incredible tunable couplers. Think of them like noise-canceling headphones for their qubits. It's quality versus scale. But what about raw speed?
Oh, you are not going to believe this. IBM has this metric called CLOPS, circuit layer operations per second. Think of it as pure raw processing speed. How fast can you actually run a program? Well, their Heron processor clocks in at over 150,000. That is a monster speed advantage, turning experiments that used to take days into something you can run in just minutes. But see, this fight isn't just about the numbers on a spec sheet. It's about vision. It's the ultimate battle of strategies. Do you perfect the science in a lab first, or do you get out there and build the infrastructure for an entire industry? And this just lays it out perfectly. Google is on a scientific mission. They're fidelity first. They want perfect, error-corrected qubits before they do anything else. IBM, they're utility first. They're building the ecosystem right now, getting businesses hooked on quantum today. It's simple. One publishes papers, the other signs contracts. This quote from Google's head of hardware says absolutely everything. They are terrified of building a useless, noisy machine. Their focus is on absolute quality. They want to make sure that when they finally scale up, the result is actual value, not just static. It's a direct shot at that whole bigger is always better mindset. But you can't ignore IBM's playbook. I mean, it's a powerhouse. They have the world's first quantum business network. We're talking over 250 massive companies and universities already using their quantum cloud. Their open source software, Qiskit, is basically the industry standard. They are building the quantum economy brick by brick right now. So just when it looked like IBM's infrastructure play was just unstoppable, Google stepped back into the ring and landed what a lot of people thought was the knockout punch, a scientific haymaker that shook the entire industry. In October of 2025, they did something truly extraordinary. They ran a brand new algorithm called quantum echoes on their Willow chip, and the results were just staggering. Try to get your head around this number. Google announced that the calculation Willow did in under 5 minutes would take the world's fastest supercomputer 10 septillion years to finish. Let me say that again. Not billion, not trillion, 10 septillion years. That is a number so big, it's larger than the entire age of the universe. To put it another way, the Willow chip was 13,000 times faster. This wasn't just, a small improvement. This was a fundamental break from classical reality, a definitive line in the sand. And here's why this was such a big deal. This wasn't like their old quantum supremacy claim. That was kind of like proving a weird custom car is fast by having it win a race that only it could enter. No, this was different. This was verifiable. It produced a real answer you could check. It was the first concrete proof of a quantum computer solving a problem in a way that classical machines provably cannot.
So, fight's over, right? Google wins? Well, not so fast. When we go to the judge's scorecard, the verdict is far from unanimous. It really all depends on how you define winning.
And what we have is a split decision. For the scientific lead, the point goes to Google. They have verifiable advantage, they're leading on error correction, but for ecosystem and business, it's all IBM. They own the cloud, they own the software. In raw processing speed, that CLOS metric, IBM takes it. But for pure qubit quality, that fidelity, that goes to Google. It's basically a dead heat.
Because let's be real, the true prize here isn't just solving science problems faster. The end game is security. A powerful enough quantum computer will be able to crack the encryption that protects literally everything. Your bank, government secrets, all of it.
And the timeline is, well, it's terrifyingly short.
Right now, adversaries are using a harvest now, decrypt later strategy. They're stealing our encrypted data, just waiting for the day they can crack it open. IBM thinks we'll see major quantum advantage by 2026. And by 2029, we could have a machine capable of breaking modern cryptography. The clock is ticking, people. So that leaves us with the ultimate question. In this quantum showdown, who are you betting on? The meticulous scientific mission of Google, focused on getting the physics perfect, or the relentless infrastructure build-out of IBM, focused on building the economy? Two roads, one revolutionary future. The fight is not over, not by a long shot.